to all. My name is Abhishek Kumar. I am working as assistant professor in Department of Computer Science Engineering, KITE, Deemed University has Ghaziabad campus. So today I am discussing about one very important topic of algorithm, that is merge sort. So the agenda for today's topic is, first of all we'll discuss about that what is the basic assumptions about the merge sort, how the merge sort is working with the help of one example. Then also we will discuss about the time complexity of merge sort. So some of you as already know, the merge sort is an example of divide and conquer design paradigm. So what we are doing in the case of design and conquer, first of all, if a problem that is large in size, so in the divide and conquer approach, there are three different steps that we are following. We are dividing the problem into different sub-problems. Then we are conquering. Conquering means we are finding the solutions recursively. Then finally we are combining the solution. So here also we are doing the same thing. Let's assume there is one sequence S which is containing n number of elements, and we want to sort this n number of elements with the help of merge sort algorithms. So first of all, what we are doing, that we are dividing the sequence into different subsequences. So the first step is divide. So first assumption is that if a particular sequence S is containing either 0 or 1 element, then in that case we are saying that S is already sorted and we are returning immediately. That means that will be the condition that will be called termination condition, or that will be called base condition. Otherwise, if the sequence S is containing 2 or more than 2 elements, so what we are doing, we are dividing the sequence into different subsequences. And to divide the sequence into two subsequences, the basic assumptions that we are doing, that we are finding the mid value, and to compute the mid value, we are taking the lower index of the subsequence plus higher index of the sequence and divided by 2. So in this case, the S will be divided into two parts, S1 and S2. S1 will contain n by 2 elements, and S2 will also contain n by 2 elements. Now comes to, we will do the same approach, dividing up to, we will divide the sequences into up to which step when the each subsequence will contain only one element. Then the second step will be concur. Concur means we are recursively sort the subsequences separately. And the third step will be combine. Combine means we will merge all the subsequences simultaneously to find the solutions of original subproblem. In the case of merge sort, the basic prerequisite condition for the merging is that if you want to merge two subsequences, then the two subsequences must be sorted. So now comes to we will see how the merge sort is working with the help of one example. So here let's assume that there is one sequence that is containing 8 different elements, and the element is 85, 24, 63, 45, 17, 13, 31, 96, and 50. So first of all, because the sequence is containing 8 number of elements, so this sequence is not fulfilling the base condition of our merge sort algorithms. So the base condition was that either the sequence contain 0 element or 1 element. So what we are doing, we are dividing the sequence into two equal halves. So first of all, because this sequence is containing 8 number of elements, so dividing into equal halves. So in the left subsequence, 85, 24, 63, and 45 is coming. In the right subsequence, 17, 31, 96, and 50 is coming. Again, we are doing the same approach for the S1 subsequences. Again, the S1 subsequence is containing 4 elements. So again, we are dividing into equal half. That will be 85, 24, and 63 and 45. Again, we are doing for the right subsequence, 17 and 31. That will be 96 and 50. Again, we are doing the same thing because in this subsequence also there is only 2 elements. So again, we are dividing into single element. So 84, 24, 63, 45, 17, 31, 96, and 50. So the figure A depicts that how we are dividing the sequence into different subsequences. Now comes to the figure number B part. Here, what we are doing the combined step. That means we are simultaneously we are doing the concurring as well as we are combining solution. In the case of merge sort, the combining step will be go from the bottom to top, and divide steps will go from top to bottom. So in that case, first of all, because each subsequence is in the left in the bottommost layer, in the bottommost level, each subsequence is containing only one element. So the all the subsequence is already sorted. Now comes to the uh, upper layer. So here, what we are doing, we have to combine 85 and 24. So the basic approach that we are following in the case of merge sort, that we are combining the both elements. The element which are smaller, it will go to the first place. The element which is larger, that will go to the second place. So here 85 and 24. 24 is smaller than 85. So 24 and 85. Again now comes to the 63 and 45. Again 45 is smaller than 63. So now comes to 45 and 63. Again for 17 and 31. 17 is already smaller than 31. So here there is no change. And 96 and 50. Again 50 is smaller than 96. So again here the same thing will happen, 50 and 96. Now comes to the next layer. That will be for 24 and 85 and 45 and the 63. Again we have to merge. So again we will do the same thing. 24 will be compared with 45 because 24 is smaller than 45. So 24 will go to the first place. Again 85 will be compared with 45 because 45 is smaller than 85. So 45 will go to the upper layer. Again, 85 will be compared with 63. 63 is smaller, so 63 is going to the next page. And there's only one element left in the left side, so 85 will be copied. Now comes to same thing we are doing in the right sub part also. 17 will be compared with 50, so 17 will go to the upper part. Then again, 31 will be compared with 50. 31 is smaller than 50, so 31 will go to the next part. Again, 50 and 96. There are only two elements are remaining in the right hand side, right part. There's no any element in the left part, so both the elements will be copied. Same thing we are doing for the next. So the original solutions is coming to 17, 24, 31, 45, 50, 63, 85, and 96. Now comes to let's see the basic simple basic idea of how the merge operations we are doing. And this is the code that is this is a simple code that is written in the Python. So first, what we are doing that we are defining one function. That function name is merge, and it is containing three parameters: s1, s2, and s. S1 is the subsequence. S2 is also a subsequence. S is the original subsequence. So first of all, what we are doing, first we are sorted the s1 and s2 into properly sized list. Then we are taking the two variables I and j. I will be used for accessing the variables of the subsequence s1, and j is used to accessing the variables of the subsequence s2. We are initializing the I and j value will be 0. Then now comes to we are taking one while loop that the we are finding that I plus j, that means the value the subsequence number of first and the second we are adding this, and then if the I plus j value will length of s, that means if no element will be greater than that, then we are comparing that if the j is the length of s2, that means in the j we are on the right side, then accordingly we are comparing the element that is going, the element that is copying from the lower level to the upper level, that side we are going for I equal to I plus plus. And this is a simple basic idea of, and if you'll see the implementation part of the merge sort, if you'll see this will take order of n time in the case of worst case time. So this is the basic idea that how we can see that the merge is doing this. Here let's do this one S1, that is 2, 5, 8, 11, 20, 12, 14, and 15, that is S2, G, 3, 9, 10. Let's do that is the I place, that means I is in the third position and J is the J is the second position. If you want to do I plus G, that means 5, then to fifth place, which value will play? 11 and 10, both will be compared. The element 10 is smaller, so 10 will go to the fifth place. So this is the basic idea that we are doing in the case of, and this is the basic how the recursive merge sort algorithm will be working. So this is the basic algo of the recursive merge sort algorithm. So here also we are defining one function that name is merge sort. In the merge sort, first of all, we are finding the length of the subsequence, that will be n. If n is less than 2, that means that if the sequence is containing only 0 or 1 element, so directly we are returning the list. If not, that means if the sequences containing more than two or more than two elements. So first of all, we are finding the mid value. We are dividing n by 2. Then we are dividing the subsequence in two parts. First will contain 0 to mid, and second will mid to n. Then we are doing the concurring. Concurring means that means again we are applying the merge sort algorithm on the S1. Then again merge sort on the S2, and finally we are doing the merge operation. And this is, if you'll see this, so if you'll see this, this is the time complexity, how we can able to find the time complexity of merge sort. Because initially in the original sequence there are n number of elements. So to n number of elements, if you want to merge n number of elements, so the total time required will be order of n. So the n will be divided into n by 2, n by 2. So if there are n number of elements, to merge that to merge the n number of elements, the total time will be order of n. So if the element will be n by 2, so that will also take n by 2, n by 2, that will also comes to order of n. Same thing, if you will see this, the recurrence function will come to T of n equal to 2Tn by 2 plus order of n. Here the 2T, here if you will apply the master theorem, so here the value of A will be 2, value of B will be also 2, and value of Fn will be, that will be your n. And if you're computing the, or if you'll compute the value of n to the power log a base b, so it will comes to order of n. Order of n to the power n, that means order of n. And here if you see, if you're applying this in the case, this is the basic, this is the example of second part of merge, second cases of master theorem, that if f of n is equal to theta of n to the power log a base b, both value will be equal. Then what we are doing in the case of master theorem, that T of n equal to theta of n to the power log a base b multiplied with log n. So it will comes to order of n log n. So this is the basic thing that I am discussing about the merge sort. So thank you all for listening, and once thank you.